Guys, what is this?
Definite integral. Definite integral. Definite integral.
At the end of the problem, when you graph a definite integral, I put this in this graphing calculator right here. This is what you're looking for. You're looking for the area under or between the curve, which is this green line, and the x-axis. If you're below the x-axis, it's a negative area. If you're above the x-axis, it's a positive area. And I hope you guys can see this in this picture. This line kind of has like a little kink in it right here. It's not a straight line. That's what you get when you graph this. But how does this look by using geometry? How would you solve this? This is a definite integral because there's a -2 and a 3 on the integral sign right here. Now this is an elongated s, and for to make a long story short, the s just stands for the sum of the area underneath the curve, or the sum of the area between the curve and the x-axis. Right here we have our integrand, and you can put parentheses there if you wanted to. But what I want to do is I want to show you guys that you can split this guy up. You can split them up into two different integrals because there's two different functions inside of it. And then the next thing, you see how the integrals are the same, and there's their function there, the integral is the same, there's their function there. And then we also can take out a scalar from each of those. From the first one, we could take out the 5, because that's multiplying to the x, and for the second one, we could take out a 1/2, because that's multiplying to the absolute value. Okay, now how do we solve this? After we know that we can break it up like this, how do we solve it using geometry? I'm going to use first the graph of x. When I graph this function, I'm only graphing between -2 and 3. And what I'm going to do is I'm going to find the area between the curve and the x-axis. And just as I noted before, the area underneath the curve would be negative. The area above the curve would be positive. The formula to find the area of a triangle is 1/2 base times height. This one is negative right here because we're going down. The height is negative, and that kind of makes the area negative automatically. So I'm just simplifying it right here, simple arithmetic. And I want to make a note that you got to make sure you don't forget to put in your scalar when you're done. That is a common mistake. It's nice to take the scalar out because it makes it more simple, but there's a good chance that you might forget the scalar as you go on solving it. So here I multiply the 5 by 2.5. 5 times 2 is 10. Where's the 10 at? There he is. And then 5 times 1/2 is going to be 2.5, which is what I get right here. Okay, now let's do our other one. Let's graph that one up. Now this one, for this function, I had the opportunity to split the integral up, which you guys might not have seen yet before. So we're going to find the area between these curves and the x-axis. And I hope you guys notice here that the absolute value function is made up of two linear functions. There's the negative x, and then there's the positive x. The negative x part of the function is between -2 and 0, and the positive x part of the function is between 0 and 3. So that's what we're going to use, those three x values to split up. So my scalar's out in front, and notice that my integral changed. It's going from -2 to 0, and that's the negative x part of the function. And the other part, the 0 to 3, is the x part of the function. This is the area of the first triangle, and then this is the area of the second triangle, and there's your scalar out in front. I want to do a little bit of arithmetic here. This is what I get after simplifying the inside, and then I'm going to add these guys together after I made a mixed number. I get 6.5 times 1/2, and I get 3 1/4. Last thing to do would be to add 12 1/2 to 3 1/4, and that would equal, well, let's go ahead and do common denominators. This is going to be a 4, this is going to be a 2, so we get 15 3/4. So that is what our original integral would equal. Just a few calculator things. If you guys had a graphing calculator and you put this into your graphing calculator, once you hit graph, your graph button's probably not going to be there if you're using a Texas Instrument. It's probably over here. You could make your graph look like this, and it'll give you the area of it by pressing second, and then my button doesn't have it up here, but you have a button up here that says calc at the very top. You press second, then calc, and then you're going to select integral or FNINT, and then you're going, and then you say enter, and then it'll shade in all the area between the curve and the x-axis, and then it'll give you the answer. You can also find the integral in your home window by pressing math and then going to FNINT. That means the integral. And then you have to put in the lower bound, the upper bound, and then the function. Now here, you'll notice I was able to write y sub 1. And you get that by pressing vars and going to y vars. And then you could select y sub 1. Why could I select y sub 1? Because in my function window, the y equals window, I have my function in the y sub 1 variable. And as you can see, it has the same answer. It gives me the same answer as what I got by using geometry.